Hey everyone, sorry for the delay. We'll get started right now. We'll still aim to finish around 5 o'clock if possible. Okay, it seems like we have a lot of people today. This is good. I guess you're all here for one of two reasons. We mentioned two different ways you can submit your final project on some sort of public repository location. So the first thing you can do, which is actually going to be the first thing we're discussing today, is to just use your instructional account and upload your code there and make it visible that way. The second thing you can do is to use a site like Bitbucket or GitHub to make your code public. And that'll be the second thing we'll discuss. So let's get started. Okay, so I'm going to be doing a lot of typing today. So hopefully, it looks like most of you have laptops, which I recommended earlier. This is good. So you can follow along through there. Okay, so I'm just going to go into my account. Okay, here we are. And I'm going to make a directory for all the code that we're going to write. So this is the git/GitHub session. Okay, nothing inside here. I'll start a really simple C++ program, and this will be our running example throughout the session. Okay, so this is just a really simple hello world program. It's only 6 lines long. And actually, let's make it even simpler for now. We'll just make it hello. And we'll save and quit out of this. You don't have to use Vim. You can use any other text editor that you're familiar with on the command line. So the most minimal option, if you want to follow along and don't want to use Vim, is called Nano. So this is an even more minimalist text editor than Vim. And you don't have to worry about which mode you're inserting stuff in and so on. You can just like start typing anything you want. Okay, and the way you exit out of this is, if you look at the bottom, you see the caret symbol and the X, which means that, at least on a Mac, you say Control X, and then it will give you this prompt over here. You don't want to say stuff, so I'm going to say yeah, sure. And just hit enter, and here's your file. Okay. Just to make sure we can compile. Looks like it worked. There's the executable, and we'll just run that. We should see the output hello. And we do. I'm going to remove the executable or the binary file for now, just so we have only the code. So we have all this, we have this code in there. And we want to make it public on our class account. What this is going to look like is we can access we can go to pages.cs.wisc.edu, and then we can go to whatever our username is. So for the instructor, that's just tilde Gerald. And he wrote a lot of HTML code that made his page look really nice. If you're like me, then you haven't written any HTML code, and it just uses the default stuff that's right here. So basically, this is a list of directories and files that are in a certain location in my account. And it's empty, that's why it's not actually showing anything. So let's go back to here, and let's see this location where that list of files is. So then if I'm in my home directory, I just need to go into cd to /public. There's some stuff inside here. There are 2 directories. These should be there. Like I never created these beforehand. These came with my account basically. We're not really interested in HTML5. Let's go to HTML. There's nothing inside here. So let's see what happens if we actually try to create something. So like, if we just create some file, and then just put something inside there, and say input. We have 1 file inside here right now. Now if you go back to the web page, we should be able to see this. Yeah, and there's this file. Let me change the name of it. Make it a text file. So I just renamed it now. And I'll refresh this page. And there's the file that we just wrote. So this is actually provided by the people who are running the instructional machines. Okay, I'm going to go back. I'm going to delete that. We don't need that anymore. It's empty again. What we want to do is take the code that we wrote, the directory that it's in, and the single file of code inside it, and copy it into that location. The way to do that is cp, that's the name of the command. We're going to be copying a directory recursively. We have to specify -r, capital R. Now we say the thing that we're copying, which is, I think it was called get session. And the destination is going to be ~public/HTML. Okay, it looks like it worked. Let's move that into public/HTML. And it's here. Just to be sure that this worked correctly, let's go back to our web page. And I'm going to refresh this again. Okay, we deleted that previous file. Now we see a folder. There's a nice folder icon saying get session is a directory. We can go inside here and you can see it got copied over correctly. If you're trying to submit your project, this is all you need to do. This is the bare minimum that you need to do. You can get all your code into a single directory, copy it over to your public HTML, and then go to this page for your particular account and make sure that it got uploaded correctly. Okay, so that's the easier way to do it. The slightly more complicated way is to use a website like GitHub to make your code public. The benefit of this, well, there are a couple of benefits. One thing is GitHub is a very well-known website, and a lot of people use it to share code, which means if you're uploading your code to GitHub, then you're basically becoming part of this really large set of shared code, and other people will be able to see your code and so on. Essentially, if you want to upload code samples for example, if you're interviewing with companies, or if you're applying to a job and they want to see what some of your code looks like, or if you're working on a very large open source project, then GitHub is basically the tool of choice. So with that in mind, we're going to go back to our home directory. We can see our Git session stuff. It's still there. We just copied it over to our public HTML folder. But now, let's go back into our Git session code. Our file is still here. And now we'll start using Git. So then, there are 2 things here that are related, but we should also make sure to draw the distinction between them. When we're talking about GitHub, we're talking about the website, which looks like this. GitHub.com is this website. And you can basically just share code over here. It's fundamentally a website. If we're talking about Git, not GitHub, just Git. Git is a command line tool that you can use to perform version control. What that means is, if you're working on a project alone, you might want to keep track of different versions of your code. Like your version from yesterday, let's call it version 1, would probably be different from the version today, which we can call version 2. And at the same time, you don't want to lose all the stuff that you had from version 1. Like, sure, it's there in your code from version 2, but at some point, you might want to go back and see, so what did I write on that particular day? What was in my code from version 1 before I added any of the other stuff after it? Essentially, what I'm saying is, it's useful to know the state of your code at any given point in time as you were writing it. And Git is a tool that lets you do that. It lets you keep track of all the different versions of your code. And you can do stuff with those versions of your code. Like you can go take a look at previous versions. You can create a commit, which is basically just adding a new version of your code on top of the previous version, and so on. So let's go back to the terminal. We're inside the directory that we already made with our code. These are all the files. So dot just means current directory, dot just means the directory outside the current directory, and hello.cpp is our code. Right now we have 3 different things, and the only one that really matters is hello.cpp. Let's initialize the Git repository here. The command is called git. Git is the name of the command. And the subcommand is called init. This is the first subcommand of Git that we're going to learn. Anytime now. Okay. The command is said it'll initialize an empty Git repository in this current directory. If we do ls-a again, we'll see all the stuff that we had before, but we'll also see this tiny little .git folder. So the .git folder, you should never touch it. You shouldn't delete it. You shouldn't go inside it. I mean, you can go inside it if you want, but then there isn't really anything interesting in there. The point is, everything inside there is used by Git to keep track of these versions of your code and so on. Okay, so that's the first Git command that you should learn. The next one is called git status. This just shows you kind of the state of your files right now, which could include things like files that you just created, files that you used to have before in the previous version of your code, but now you modified, and files that you haven't modified in your current version of the code. Right now, we don't even have any versions of our code, we're just starting out here. So Git is unaware of everything. It just sees that there's a file hello.cpp, and it says, okay, I see a file over here. I haven't actually done anything to it yet. So it's your responsibility to make me, Git, aware of the existence of that file. And that's what unpacked files mean. And again, if you compile again, we do this, we can run our code. Now if we run git status, we'll see that there are 2 files that are unpacked. There's a.out and there's hello.cpp. We want to make Git aware of hello.cpp. We're not really interested in a.out. Like, you can go inside it. Like, we don't really care if Git knows what this is. We're not going to be looking at this binary at any particular point in time. Let's just quit out of here. All that really matters is the code. So let's get rid of a.out. We'll do git status again. We have our single files, as soon as this runs, hello.cpp. And we want to create what's called a commit. In Git terminology, that just means a commit is basically a version of your code. So our initial commit should have all the files that are in here. The way you make a commit is by writing a command git commit, and you have to specify a message. So we'll say -m. Initial commit. This is kind of this convention. Initial commit is usually the message for the very first commit. So let's run this and see what happens. It says, it shows us all this stuff again that we knew beforehand. And it says, nothing added to commit but untracked files present. So that seems to suggest that our commit didn't work correctly. We can do git status again. And we see hello.cpp is still untracked. Git is still unaware of what that file is. Now, in some version control systems, like I think SVN is a canonical example, there's a different system called SVN in which the commit subcommand actually takes everything inside the directory you're in and then puts that in a commit in a version of your code. In Git, there's actually one thing you need to do before you make a commit, which is you need to say, I'm going to add hello.cpp to something called the staging area. Yeah, but sorry, just give me a second. I think I'll have this working in a couple of seconds, hopefully. Okay, so it's on the screen again. Let me just dim the lights again. It's more settings. Okay, that looks pretty good. Right? Yeah, so we said git add. This adds the specified file to the staging area, which is going to change our status right now. So the staging area is just stuff that's going to go into the next commit. And that's why hello.cpp is listed under changes to be committed, rather than untracked files. So now we can actually commit it. We can say initial commit. And if we do git status right now, then our working directory is clean, which means the file is still there, but it's been included in the last commit. And at the present time, Git doesn't see any changes to that file that should go into the next commit. If we want to see what all the commits look like up to this point, we can run git log. And this just says we made this initial commit. It has some of my information. And we can exit from this just using Q. Here we go. So right, so far we covered git init, status, commit, add, and log. Let's say we go back to our hello.cpp and we want to make a couple of changes. So the next version of our code will have a slightly different output when we run it. Instead of saying hello, it'll say hello world. Okay, I'm going to save and quit from there. Now, just make sure we can still compile. Okay, that looks good. And now here is hello.cpp. We made some changes to it. This listed as modified. And we created our binary again, a.out, which is listed as untracked. When we're adding our files, we need to be really careful to add only the files of code and not the binaries. Which is why we say git add hello.cpp like this. And we don't say git add a.out. So yeah, just in general, in Git, it's a bad idea to commit really large files, really large binaries. So then, we can leave a.out there, but we'll just say git commit dash. Actually, wait, I want to show you one more thing. So, if you want to take a file that, okay, so if you want to discard all the changes that you made to hello.cpp, you can say git reset head dash dash and then the file name. So this is going to take the stuff in changes to be committed for hello.cpp and change them back into just modified. So Git is aware of it, but those changes right now are not going to be included in the next commit. And the reason I wanted to do that is to show you this one other command that you can run, git diff. So git diff takes all the files that are in changes not staged for commit and shows you what they look like. So this is basically the change that we made. We said we removed that line of code that says cout hello NL and we're replacing it with something that says cout hello world NL. This is the difference between the current status of the file and the way the file was in the previous commit. Okay. So let's add it again this time. Git add hello.cpp. And we run git status again just to be sure that it's still there. Okay. If we want to see the changes in the file right now, git diff isn't going to do exactly what we want. So right now, it just says end all the way to the top because the file is actually empty. The diff is actually empty. And the reason for that is because git diff on its own just shows you the changes that you make to the file that have not yet been staged, that have not yet been listed under changes to be committed. If you want to see the difference between your changes to be committed and the previous commit, the commit is git diff dash dash staged. So now this will actually show us the difference that we want, which is the same as before, except now it's been staged. So our staging area that's ready, we'll create a second commit. So this time I'll make the message, change the output message. Yeah, I'm just going to ignore these warnings for now. If you haven't used Git before and configured it on your accounts, then you'll probably be seeing the same thing right now. Just to make sure it worked. Git status, we have a.out, we don't really need that anymore. And we'll do git log again just to see what it looks like. And here we are. It says we have our initial commit at the bottom. And on top of that, we made our last commit, change output message. Okay, I'm going to press Q to quit from this. Okay, so this is pretty much the bare minimum that you need to know for Git. I'm going to move on to the discussion about GitHub. Okay, so here's GitHub, the website. And I'm going to just sign into my account. Okay, that's my username, and let me just enter my password. And now it's going to prompt me for two-factor authentication, because two-factor authentication is good for you. Okay, this will take just a second. So, here's my GitHub account. Actually, my account will look like this. Yes, so I have all these different repositories here. These are just different pieces of code that I've created in the past. So, I'm going to go back, and I'm going to say, let's start a new project. I'm not going to read the guide, I'm just going to start a new project. Let's say the name of my repository is just going to be Git session. Or actually, more descriptive. Yeah, let's just say Git session. And a lot of description. Here we go. Okay, so name is set, description is set. We'll say it's public. We don't need a README, at least not right now. And that's pretty much all we need to do. Let's create the repository. Here we go. All our code is going to be here, eventually. Right now it's just saying how we can actually get the code that we wrote and put it onto this web page. So what we need to do is push an existing repository from the command line. And we need to run these two commands to do that. So the first one is git remote add origin, and then that thing. So I'm going to copy this. Okay, copied. And I'll go back to the terminal, and I'll run that. So git remote add origin, that thing. Just an explanation real quick. The different parts of this command are git remote is the subcommand of git. Remote add means we're letting our repository right here, our local thing on our computer. We're letting it know that we're going to be adding some information about a remote repository that it can push changes to and pull changes from. We're going to be naming that thing origin, which is just standard. And the location of the remote repository is github.com / my username / repository name on github.git. So I'm just going to hit enter. Okay. Now, let's see the next command we need to run. Git push -u origin master. Okay, let's do it. Git push -u. So git push means that we're going to take our code and actually push it to the remote repository. The remote repository we've already decided is origin. And then we say master, which is the name of the branch. I'm not really going to be going into branches today. So let's run this and see what happens. Yeah, it prompts us saying this message. Yeah, we know GitHub is safe. And then it gives us this warning, or actually, sorry, it's error. Payload could not read from repository. Make sure you have the correct access rights and the repository exists. So the reason this is happening is basically we actually don't have permission to push to GitHub from our account. And in fact, if we just refresh this page, we'll see, yeah, we're still seeing these instructions. So GitHub is unaware that we were even trying to connect to it. So the very first time you use Git on a machine, there's some stuff that you need to set up. Or sorry, the very first time that you connect to GitHub on a machine, there's some stuff that you need to set up. You need to make GitHub aware of who this machine is, who we are. And we do that using something called an SSH key. So let's take a look at this. Yeah, so SSH keys are a way to identify trusted computers without involving passwords. This is kind of nice. So GitHub will be able to tell who we are, and we'll be able to push to GitHub after we set up all this stuff. So there are 4 different steps here: checking for existing keys, generating a new key and adding it to the SSH agent, adding a new key to your GitHub account, and then testing your SSH connection. So let's go through all of these in order. Checking for existing SSH keys. Okay, open terminal, we did that. Step 2 is run that command, ls-al, to specify that directory to see if any SSH keys are present. So there's a description here. It lists the files in this directory if they exist. ls-al, our home directory /.sh. Let's see what's going on inside here. Okay, so there's dot and dot dot. Again, we ignore those. I happen to have something called known hosts, which isn't really important. And that's all we have. Okay, so we have a known host file. Step 3 over here says check the directory listing to see if you already have a public SSH key. By default, the file names of the public keys are one of the following. So then, out of these 4, well, we don't have any of those, or at least I don't. So let's see what else is there. We don't have an existing public and private key pair, or don't wish to use any that are available to connect to GitHub, then generate a new SSH key. So that was step 2 from the previous page. Essentially, this is telling us, yeah, we don't have our SSH key that GitHub needs, so we're going to have to create it. So let's do that. Go back here, generating a new SSH key and adding it to the SSH agent. Okay, series of steps. Open terminal, yeah, you did that already. Paste the text below, substituting in your GitHub email address. Okay, so there's a command called SSH keygen. This is pretty standard on most Unix-like machines. SSH keygen. We're going to be using a protocol called RSA to set up our key. The RSA algorithm requires something called the block size, which in this case is going to be 4096. And then we have to say our email address. It's going to copy that beginning part. Go back to the terminal. Okay, we're still here. Paste. And I need to enter my email address, which for me is just, this is my personal address. Okay, it's telling me to do something. Let me go back to the instructions. Okay. When you're prompted to enter a file in which to save the key, press enter. This accepts the default file location. So yeah, that was the message that I just saw. Enter a file in which to save the key. So I'm just going to press enter. The next thing I'll have to do after that is type a secure passphrase. Okay, so I expect to see these 2 messages as soon as I go back. So I'm just going to hit enter. We're going to use the default file. Enter a passphrase. I'm going to use a passphrase. It's not incredibly secure or whatever. And there is a bunch of stuff that we saw, but I don't think this is really important. So then, hopefully that's been created now. But before I do this actually, let's see what got changed. If we go inside here again, inside our .ssh directory, then this is what it looks like. We created these two new files. We created IDRSA and IDRSA.pub. So let me just change this command a bit. Let's cd into there and see what these look like. Okay, so IDRSA.pub. This thing right here is our public key OS as well. Okay. Let me just write that. Okay, this is our public key. And when we're using the RSA protocol, every public key has a corresponding private key, which is going to look like ID RSA. You should never do what I just did. I just printed the private key, now you can all see what it looks like. This is one of the worst things you can do from a cryptographic standpoint. So I'm gonna have to delete these now and basically do those steps all over again. But just for demo purposes, I'm actually doing this right now, just so you can see what it looks like. So the private key looks like this. It's really long and there's a bunch of information at the top. Okay, so then, since I just showed you all what those look like, I'm going to delete those now because they're kind of useless. And now we need to go back to our Git session stuff. Okay, we're back. And I'll just run those steps again. So let's take this thing again. Okay, so we're generating a key again, same file, upgrade, passphrase. All right. And those should have been recreated now, and I'm not going to open the private key this time. All right. So that's done. We have to do these steps now. Adding your SSH key to the SSH agent. So to ensure SSH agent is enabled, so this is going to be this command over here. I'm just going to copy it. Start the SSH agent in the background. I'm not really going to explain what that is. It's not too important. Okay, we saw an output, agent PID something. Okay, so it says agent PID some other number. That's fine. And now we add our SSH key to the SSH agent. Again, I'm just going to take this command and say, okay, I'll copy that. Now, paste it here and run it. We're adding our private key to the SSH agent. I'm just asking for my passphrase. There we go. So this is done now. That's the second step. We're done with that. Third step is adding a new SSH key to your GitHub account. So all the stuff that we did right now is on our computer. GitHub doesn't know about any of this. So we need to make GitHub aware of these keys that we made. So there are two separate files. There's the public key, which is ID_RSA.pub, and there's the private key, which is ID_RSA. If we give ID_RSA.pub to GitHub, if it knows our public key, then through the power of cryptography, GitHub actually knows that we have the corresponding private key. I don't think I explained that quite right, but basically what I'm saying is if GitHub has our public key and they want to communicate with us, then we can actually prove that we are the owners. Since we have our private key, we can actually use that to tell GitHub, yeah, so we have the private key corresponding to the public key that we already gave you. So we are who we say we are. Now please take our code that we're about to push. Essentially, that's what GitHub is doing. It's using cryptography to do all this stuff. If you're really interested in taking a computer security class, it's actually a really fascinating subject. But I'm not going to be going into it anymore here. All we need to do now is make GitHub aware of our public key. So first step, copy the SSH key to your clipboard. Unfortunately, we don't have this command for two reasons. First of all, it doesn't exist here. If you try to run it, it just says, can't find it. Did you mean any of these commands, or did you want to install it? So that's one problem. And the second thing is, the pb copy command is supposed to copy something, like you can feed it an input, and then it copies that input over to your clipboard, and then you can paste those wherever you want. If you're in the labs working on those machines, then that would be kind of nice. If you're on a Mac like I am, on a separate computer, and you're trying to run that from terminal, you wouldn't want something like that to work in the first place. If you're able to run that command, and it can actually modify something, if you're able to run that command on one of the lab machines, and it's able to modify something on your Mac, that's actually pretty terrifying. So this sounds like a huge security vulnerability, so we wouldn't want to do that in the first place. So unfortunately, instead of running pbcopy to copy over our public key, we're going to have to do something a little bit different. So this tip over here is useful. Open the file in your favorite text editor and copy it to your clipboard. Okay, I'm going to do something even better. I'm going to go back here. Here are our files. Now I'm going to print out id_rsa.pop, the public key. So here are the contents. I'm going to copy this very carefully. Control C, or Command C, I guess. And copy it over now. And now, what do we have to do? We have to do a bunch of stuff to get it into GitHub. So basically, we go to our settings. We click a particular tab called SSH and GPG keys. We click New SSH key. Okay, I think that's enough for now. Let's do those things. So our settings are up here in GitHub. You can just click on that. You see a drop-down menu. Now we'll go down to settings. So we see this page with a bunch of different links. The one we want is called SSH and GPG keys. Let's do that. And these are my SSH keys. This is the one from my Mac. This is the one that I can use to push code from my Mac to GitHub. So I'm going to leave that there. We said we want to create a new SSH key. So we did steps 2, 3, and 4 now. What's left? In the title field, add a descriptive label, then paste your key, then click the button that says add SSH key. Okay, sure. So I'm going to just create that. So I'm just saying UWM because this is my UW Massive account. I'm going to paste the key that I already copied in here. Okay, we're going to clean out my clipboard. And this should work. Let's say add SSH key. And it didn't ask for my password, surprisingly. So it looks like that's it. So we finished the third step. Now, here we are. Yeah, I didn't need my password. The last thing we need to do is test our SSH connection. Okay, this is just verification that everything that we did actually worked correctly. So what we're going to do is we're going to go over here and we have to run something. We have to run this command. We're going to SSH into this thing over here. This is why it's called an SSH key. It actually gives you permission to SSH. So I'm just going to paste that here. And it's giving me some kind of warning message. It says, hello, you successfully authenticated, but GitHub does not provide child access. This is actually correct. If you go over here, this is what we want to see. So there's the desired message, and it contains my username. Yeah, it did. Okay, we're connected to GitHub. We can actually push code now. So let's do that. So the command was git push -u. Actually, wait, I'm in the wrong place. Yeah. So here we go. Here's our code. The status. Okay. nothing to be committed except that file which we're not going to commit. Here are the two commits that we're going to make public now. These are going to be accessible on GitHub now. As soon as we run git push -u forwarded master. The same command that we tried to run earlier, except it should work this time. Okay, there we go. This output seems promising. Now let's go back to GitHub. Okay, let's go back. And let me refresh this page now. Hopefully we'll see our code. Yep, there's our code. It says 2 commits. We have this file, and we're good. So that's essentially the way that you use Git along with GitHub. You say that you make a bunch of commits, and then you push them to GitHub. Typically, what you want to do is you want to make one commit at a time, and as soon as you run git commit, as soon as that command works, you should also say git push immediately after. So every time you make a commit, it's also pushed. It also becomes public. In general, at least for this class, that's probably what you want to do. Okay, so all of this is useful if you're the only person working on your code. But for your projects, you're going to be working in teams of 2, which means both of you are going to want to push your code to GitHub. And not only that, but also pull the other person's changes from GitHub to your own copy of the code. So I'll show you what that looks like. I'm going to exit from my instructional account right now. I'm exiting. I'm not on Royal Dash 03 anymore. This is my Mac. This is me. So we want to take the code that we made, or that I made from my instructional account, and pull it over to my local computer. So there are 2 commands here. There's git clone, which is when you run the very first time you want to take all your code. You want to get all your code over. And then there's git pull, which is every subsequent time you want to pull changes in. So we're going to say, if I can do this. This button over here, clone or download. Okay. We are going to say clone that thing, and copy that. Git clone this whole thing again. This should look familiar. This is what we used for git remote add. So this is basically the repository as it's located on GitHub. So let's clone that. There we go. ls. I have now something called git session. This just got created. And our code is here. In fact, not just that. We have .git and below.cpp. So the really important thing here is .git. This actually has all of the history that I used, or that I created when I was using my instructional account. So we can run all the commands that we wanted. Like, here's our history, our git log, git status. There's nothing here, there's nothing to be committed because a.out was never actually made accessible to Git, and consequently to GitHub. So it was never pulled when we ran git clone just now. Okay. Okay, we're kind of running out of time. I'll show one thing really quickly. So let's say I want to make a change right now on my Mac, not on my instructional account. Then I'm going to add a README file. In general, this is good practice for your projects that you're making public. There we go, just adding a quick message. I'm going to save and quit that. There's the file. We just added it. It says it's ready to be committed. And we'll just say we added the README. There we go. It should be committed now. Excellent. And since we just committed, we should also push. Okay, we pushed to GitHub. If we go back to GitHub here and refresh this page, we should now see 3 commits, and there's our new file. And GitHub has this nice feature where they actually show your README down here on the main page of your project. Okay, anyways, let's go back to the terminal. Okay, let's go back to my account. Okay. Right now, these 2 different copies of the repository on these computers are out of sync. This one only has 2 commits. So we will pull all the changes that got made to origin, to master. And there's the 3rd commit now. There's the new file that got created, readme.md. And this is our status. Again, a.apt is on our instructional account, hasn't been added to Git at all, so it's still there. Okay. Okay, it's already past 5, but we do have the room until 5:30, but if you need to leave right now, then you can leave. If we have a couple more minutes, then I think in the next 2 minutes, I will try to go over one additional topic very quickly. Okay. I was doing something strange right now, which is I was making changes from my account, or from my CS account as myself. And then I was also making changes from my Mac while I was logged in as myself. So I'm the same user here. When you're working on your projects, you're going to have 2 different people, which means that the person who makes this GitHub repository in the first place is going to have to add a collaborator. If you don't, then that person isn't going to be able to push. You're going to have a bunch of errors. So this first link is the one we want. And it gives us a series of instructions. So then we'll go to settings, and then we'll click collaborator to the left. And when we go back to my GitHub page, this settings, the repository settings, collaborators, and we have a place to add collaborators here. Okay, under collaborators, start typing the person's username, then select from the drop-down menu and then add them. That user will receive an email inviting them to make changes to the repository. So if I want to add the instructor, I happen to know his GitHub username, so I can type that in. There we go. And it shows up right here. So then I can add him through this. And then he would also be able to make changes, to push changes to the repository, to pull my most recent changes and so on. Okay, so I'm not going to do that. Let's go back. And yeah, last thing I want to show you is if all of this was really fast, which it probably was, and you want to learn more about Git but at your own pace, there are a bunch of tutorials online. And in particular, I actually really like this book. It's available online. It's a very easy tutorial to Git. It tells you everything you need to know. This is actually how I learned almost everything I need to know. And I recommend reading section 1 and sections 2.1, 2.2, 2.3, and 2.4. I think if you can get through those, then you will have a very solid understanding of how Git works and you'll be able to use it, not just for this class, but also for future classes and future projects. Okay, yeah, I'm already 6 minutes over, so then I'm just going to end it right there. I'm going to be updating the repository that I just made. I'll leave it public, and I'll add more stuff, more information about these last few topics that I discussed really quickly just now. So if you want to refer back to that, then you can do that. Okay. Thanks everyone for coming.